Hello friends, welcome back to the full stack inventory management system tutorial. In the previous video, we implemented pagination, filtering, sorting and CRUD operation, create, read, update, delete for our product APIs. You can check it out here, playlist link in the top right corner. But there's one big challenge. Every time a request is made, the server queries the database, making it slow. So let me show you in the action. Let's see these things. Suppose we have the more than 100 products in our system and I want to fetch the 100 products at a time. So I'll put the limit 100. Now if I send the request, so you can see it took 28 milliseconds to fetch the records directly from the database. To solve these things, we are implementing caching with Redis to make our API lightning fast. If you want to know detail about the caching, why we use the caching, what is caching, I created a detailed video on the caching. You can check the link in the top right corner. In this video, not all the caching, we will also improve monitoring and debugging by adding a request logger middleware. So in this video, we will understand why frequent database queries slow down your app, store and retrieve cached response for faster API response, and when to invalidate this cache, keep data refresh while improving speed, and also the log API request to improve debugging and monitoring by the request logger middleware. If you missed the previous videos in the series, you can check out the full playlist here in the top right corner, also in the description section. So by the end of this video, your API will be blazing fast, efficient and optimized for real world application. So let's get started and boost our backend performance. Now I'll jump to the VS Code where we left in the previous video. First, I will implement this request logger. So I'll go to the file src. Inside helpers directory, we have this logger.js. Here I will put the request logger middleware. This middleware logs HTTP request with details like the methods, URL, status code, response time, and request body. Logger middleware, request logging middleware. And it will have the logger.info, request.method, origin URL. I want to also log the total time taken to process this request. So I will take the const start time, and next I will put the response dot on finish. I will take the response time and I will log this response time, and I will remove this. So it will help monitor API performance and track slow request. Now I will go to our entry file app.js, and here I will use this middleware. So first I will import it, const logger src helper logger, and just below this middleware I will use the logger dot request logger. Now let's start the server and see. I will start the server. Command is the npm start. You can see server started listening on port 3000 and connection established. Now I will go to the browser and access the Swagger documentation, localhost 3000/API docs, and here I will made request. So let's try the login route, execute, and here you can see it's documented this, the post, the login route, the status, and the time it takes to process. We can see these things also in our log file app log.js. So here you can see, here it's the info of the request logger. So next, try with the correct response, and I will log in with the customer@gmail.com. Now I'll make request, and here you can see it's the correct credentials, and we got the 200. Now if I go here, you can see we have the post login 200, and it took 239 milliseconds to process the request. But one thing it's missing here, I want to log also the request body, what I am passing, so that I can track this also. So let's add it. So I'll go to the logger.js. I will take the log message in the variable log message, and next I will include request body if it's exist. So if request body is exist and have length, then I will put into in the log message, and I will log this here. So inside log.info I will have the log message. Now let's see this thing. So now if I request again, here you can see we have the request body also in the log. And also if I go to the log file, here we have this request body, what is being passed. Next, I will establish a Redis connection for caching and real-time data. So for this, you need to install the Redis on your machine. So I will show you how you can install Redis on your machine. So just go to the Google and search install Redis on Windows. And in the Redis official site, redis.io, you can install Redis. So here it's mentioned Redis is not officially supported in Windows. You can install Redis in the WSL, Windows subsystem for Linux. So you need to install the WSL. Here is the guide how you can install the WSL. So you have to go to the PowerShell or terminal. So I'll go to terminal here, and here you have to run this command wsn install. Just copy it and run here. So it will install the WSL in your Windows, and when it will install, please restart your machine. And if you search with Ubuntu, you will get like this, the Ubuntu app, and you have to click on it and have to open the Ubuntu terminal. Next, if I go to the install Redis on Windows, so after installing the WSL, you have to run this command to install Redis. Here we have this command. So my Ubuntu started. The first command is this one. You have to run this command first by copy and right click. So here you have the sudo command. So when you will install the WSL, it will ask a password. So keep the password secured and save it. It will be needed for the future purpose whenever you will install any software to the WSL. So here I will provide the password. So I already installed, so that's why it's giving me this warning. I will not overwrite. So I'll cancel it. And next you have to run this command, the echo. And next you have to run this command sudo apt-get update. And next you have to run this command sudo apt-get install Redis to install the Redis. Whenever Redis will be installed, you can check the status Redis is running or not by following this command. Sudo service Redis server. Let me clear these things. I will not install this. status, and you can see active is inactive, date it's not running right now. So you can start on stop by using the command sudo service redis server start. It will start the Redis server, and you can check the status. Now it's active and running. You can stop also by using the same command stop, and you can check the status. Now it's inactive and stopped. After installing Redis in your machine, go to the VS Code. Now we will configure a Redis client using the IO Redis library. So I will close all the tabs here, and here I will install the IO Redis. The command is the npm IO Redis. It's successfully installed. Now I'll go to the database, and here I will create a new file redis.js, and here I will take the Redis. I will import it, require IO Redis. Next I will create a new Redis client instance. Next I will handle the Redis connection events, handle Redis connection events. First, when it will connect, I will log this. For this, I will take the logger from the helper, logger helper. So dot slash src slash helpers slash logger, and here I will log it. So here Redis, I will keep it in capital. Next, client dot on in error. I will log the error message, the Redis client error. So it will listen for the error events. Now I will export this client. So these files actually centralized Redis instance for easy reuse across the app, handles error gracefully by logging issues, and logs Redis connection status by monitoring. Now I will import it into our entry file so that when servers start, I can see the Redis is connected or not. So here I will import the Redis const Redis client require from the database Redis. Now if I start the server, I should see the Redis log. Here we have a issue. So let's check. We don't have the IO Redis. We have the IO Redis, not IO hyphen Redis. Now it should be fine. Now you can see it's listening on port and database connection is established, but the Redis I am getting error. So let me fix it. Redis is currently not running. So let me start the server. So I started it. Now you can see the Redis client connected. Next, I will go to the product controller.js and implement caching using the Redis to optimize the retrieval of the products. So I will first import the Redis instance, const Redis client from the Redis database. I'll go to the parent directory and I will import it from the Redis. Now in the get products, I will take the cache key. Let's put the command cache key. Next, I will check if the key exists in the cache. For this, I will take the const cache data from Redis client.get cache key. If cache data is exist, so I will return the success immediately. I will not query the database. If it's not found, the query is executed to fetch products data from the database. And next, I will store it into the cache. Save the data in the cache. So Redis client.set with the key, and I will stringify the data, and I will keep it for 5 minutes. So here I will make it 300. Here we have this TTL, time to live, which is the 300 seconds, 5 minutes. So this will reduce the database load by caching product data, improve response time for frequently accessed data. So let's see how it works. So really we start the server in the node by using the node mon. So whenever change happen, it will start the server. So for this demo, we will use the Postman because in the Swagger we will get the response time. So I will open the Postman. So I already have the routes. So I will log in with customer and get the token. So login successful. Here you can see. And I will get the token and go to the get products. I'll use the token, the customer token to fetch the products. So here I have the page size 1 and the limit 10. But before that, let's check if we have anything in the Redis cache. So I'll go to the Redis CLI, and here you can type this command, the info space. You can check if you have anything in the Redis cache. We don't have anything. So now post this request. So here it's put product retrieved successfully, and we have the data here. Now let's enlarge it, and we have this data, 10 data we have. And now if we check this info key space, you can check. You can see we have the one key and we have this TTL also. And if you check, the TTL is decreasing. So when 5 minutes will pass, it will automatically delete it from here. So first time it took 61 milliseconds to fetch the data. It retrieves the data from the database. Now I will retrieve from it the cache. And you can see we have the faster response, 21 seconds. You can also check from the log. So first product retrieval time was 47 milliseconds and next 11 milliseconds. So we'll check again after 5 minutes. I can show you we are fetching the data from the cache, not database. So I will update a product with the product with the ID 2 from the wireless headphones to wireless headphones, headphone updated. So I will log in with admin. I will get the token and I will provide here and I will update it. So product updated successfully. You can see we are getting this response from the database. But if I fetch the products, so you can see it's not updated because it's returning from the cache. I can show you from the database itself. So let me go to the database and select name from products. Where ID equal to 2. Here you can see the name is updated, wireless headphones updated, but here I am getting the wireless headphones. Now check the TTL. It's removed. Now if I fetch again, I will get it from the database and the database, and it's again cached. So that's we are getting the updated response, and here I am getting from the cache. Here you can see, but we have the problem here. So while we are updating the product or changing the product or create new product or deleting products, we have to remove the cache. So we have to clear all the cached keys to ensure the cache does not serve stale data. So we'll implement this. So here I will write clear cache when product change. So here I will create a function const clear cache. I will use here the flash all method. So await Redis client dot flash all. So flash all basically will clear all the cached keys. So I will apply after the create product. So here clear cache, await clear cache, and next after update product, clear cache, await clear cache, and also the delete product. So our server restarted. Now we'll see. So let me check our cache. We have this. Now we'll update again. Update it again. So it's updated successfully. Next we'll get products. And you can see it's fetching from the database, not cache, and it's cleared the cache. You can see the updated TTL here. Now store the products in the cache for the different keys. So we have the page 1 and the limit 10. So we already stored it. Now I'll store with the page 20. It will create a new key in the cache. We also add the sort by and the order. We also add the sort by and the order. So now if I list all the keys stored in the cache, so the command is the key star. You can see whatever we requested the products undefined one, the page was 1 and the limit was 20. This key stored this key and also the price under description. But here if the search is long, it inflates the key size. Very long keys increase memory consumptions, especially if stored in large volumes. So instead of storing the raw values, I will use the hash value. I will use the hash value to create the cache key. Now I will go to the VS Code, and here we have this cache key, and here I will take the function crypto const crypto require crypto, and here I will define a hash function const hash value. It will take the value and return crypto.create hash dot update value, and it will also apply the replace and to lowercase, and it will return the hash value by the provided value. Now I will apply the for the cache key. So here hash value, and I will provide the parameter. Now let's stop the server and run in the debug mode so that I can show you the step-by-step process. So I will start the server in the debug mode. So here we have the issue, the unexpected end of input. Let's see. So if you say here we have this return, we don't need this, and if we use the shorthand expression, we don't need this bracket. It's actually returning the only one value, so it should be fine now. So you can see it's running, and now I will send the request uh, first with the limit 10 here, and if I go here, so here we have this cache key, and if I execute, you can see we have the hashed value of the cache key. Now it will not get the cache data is null because we have the different cache key here. We don't have any cache key, so it will store the data of this product with this cache key. This data, the 10 records. Now if I check, so we have this key, and you can see it's took longer time. Now if I request again, now we can see the execution. Here we have this cache key. It will fetch the cache data, and you can see it fetch the cache data from the Redis, whatever we stored, and it will not go to the database, and it will return the successful response from here, from the cache, not from the database. Now we can try with changing the limit. It will generate the different cache key. So let's see. So you can see it's generate different cache key, and this cache key not present, so it will go database and it will store the data with the cache key, and next it will return the response here. And if we see here the keys, we will get a different cache. Now let's remove the breakpoint and let's try with different one, like the sort by order and hit. And if we see here, we have another cache key. Perfect. I will wrap up video here. We explored how to optimize API performance using request logging, middleware, and Redis caching. For product data, we implemented middleware to track API request and cache product response, ensuring the faster API performance and reduce database load. By now, you should have a clear understanding of how middleware enhances logging and Redis improves performance time by caching frequently requested data. These techniques are crucial for building scalable and the high performance application. If you found this helpful, don't forget to like, subscribe, and hit the notification bell so you never miss future deep dives into backend optimization, caching strategies, and scalable APIs. Got questions or want me to cover something specific? Drop a comment below. I would love to hear your thoughts. Until next time, keep optimizing, keep scaling.